So, today we're going to dive into this invisible rulebook that's secretly rewriting the future of our energy, our factories, and yeah, even our cars.
So let me ask you this. What could a smart solar panel possibly have in common with a self-driving car? I mean, on the surface, it seems like not much at all. But under the hood, they share a pretty powerful secret. And that secret is a hidden intelligence that is constantly, and I mean constantly, learning and adapting to the world around it. Okay, so let's get into how this whole thing actually works. To really get what's so special here, we first got to look at the classic approach, a basic control algorithm. Honestly, the best way to think about it is like a simple recipe. You follow the exact same steps with the exact same ingredients every single time. It's consistent, sure, but what happens when something unexpected comes up?
And this just nails it. On one side, you've got that fixed recipe. It's precise, but it's totally rigid. But on the other side, you've got the master chef. The chef knows the recipe, of course, but they also taste, they feel, they observe. You know, if the oven's running a little hot, they adjust the time. And that ability to adapt to what's happening right now, well, that's the absolute game changer, right? It's all about that adaptability. So let's see how this actually plays out when we're talking about something as big as, powering the entire planet.
We'll kick things off with something that really affects all of us, energy. And more specifically, how we're making our energy systems way smarter and a whole lot more efficient.
So here's the fundamental problem, especially for renewables. The world is just not predictable. The sun isn't always shining with the same intensity, the wind isn't a constant, and our own demand for power is all over the place. A fixed, rigid system just can't keep up with that chaos efficiently.
So how do you teach a solar panel to be that master chef? Well, one of the most common ways is a method called Perturb and Observe, and it's actually beautifully simple. First, the system makes a tiny little change. That's the perturb. Then it measures what happened. That's the observe. Did the power output go up? Great. It keeps making changes just like that one. Did it go down? Okay, no problem. It just tries the opposite way. It's this constant tiny little feedback loop of trial and error, always hunting for that perfect sweet spot. And the results? They're honestly incredible. This process, it's got a technical name, Maximum Power Point Tracking, or MPPT, allows solar panels to operate at over 99% efficiency. Just think about that. It means they are constantly tweaking themselves to squeeze every single last drop of energy from the sun as conditions change all day long.
And it is not just solar panels. This kind of adaptive thinking is popping up everywhere, in smart grids that have to balance power across entire cities, in hybrid cars to manage their batteries, and even in geothermal systems to get the most out of them. So yeah, it's pretty clear. Adaptation equals efficiency. But what happens when we give this kind of power to machines that actually move?
Let's shift gears now and move into our next section. The world of robotics and autonomous systems. This is where the ability to adapt isn't just about being efficient, it's about safety and just working at all.
Just look at the range of problems here and the really clever solutions. An autonomous car uses AI to plan its path through messy traffic. An industrial robot needs advanced trajectory control to do super precise tasks. And for something really out there, like an underwater vehicle in a place it's never been before, engineers use this cool blend called neuro-fuzzy control. Even keeping a humanoid robot from tipping over requires these unbelievably complex algorithms that basically mimic our own sense of balance.
Of course, with machines this smart, the number one question becomes trust, right? How do we make sure they're safe? And this quote really hits it home. It all comes down to tons and tons of testing, resimulation, and validation to make sure these systems aren't just clever, but that they're rock-solid reliable.
This chart really lays out the priorities. Yeah, efficiency is important. You can see that. But safety and reliability, they are without a doubt the top goals. The algorithms have to be tough enough to handle anything that's thrown at them, every single time. So, whether we're talking about generating clean energy or guiding a machine down a busy street, the pattern is exactly the same. Adaptation is everything.
All right, so let's pull all of this together and take a look at the really big picture here.
So if there's one thing to take away from all this, it's this. The ability to learn and adapt in real time isn't science fiction anymore. It is the fundamental engine that's driving our most advanced technology today. These algorithms, they're like an invisible intelligence making our world safer, more efficient, and way more responsive. They're the master chefs working behind the scenes, constantly tweaking the recipe for a better future.
And that really leads us to one last pretty fascinating question. We've taught them to optimize power grids, we've taught them to drive cars, So as our world gets even more complex and even more unpredictable, what new frontiers will we ask this invisible, adaptive intelligence to conquer for us next?
Thanks for tuning in.